Okay, here we are. Hello, everyone. I think you should hear me. My name is Michael Schmela, and I'm the Managing Director of TaiyangNews. I very much welcome you to the first TaiyangNews event in 2021. You hope you had a very good start into the new year, which should be a very exciting one for solar. While our technology proved to be very resilient during the pandemic over the last 2 years, it has been demonstrating growth even in times of severe supply shortages. It's a difficult word. Only the sky should be the limit once these adversary conditions are left behind. And we all hope that this is soon. Maybe the second half of the year. Anyway, technologically, a lot has happened in solar recently. We've seen incumbent PERC reaching its practical efficiency limits by using some tricks on the module level also to reach levels above 21.5%. And now we see at least the leading companies having to opt or at least look seriously on what they do next. In today's special focus webinar, we will discuss why the time is right for Topcon solar modules and why it is the natural successor to PERC. We are very glad to have JinkoSolar as a driver in Topcon R&D and a leader in commercialization of the technology sponsoring this webinar. In the next 90 minutes, I think we have to go very fast because we have a lot of speakers. We will first hear from Professor Dr. Robby Peibst, Head of Emerging Solar Cell Technology at Research Institute ISFH, brief R&D technology overview with emphasis on the success story of polysilicon on oxide-based passivating contacts, which is commonly also known as high-efficiency Topcon solar cell technology. Afterwards, JinkoSolar's global procurement and product manager, Cong, will introduce the company's new Tiger Neo module based on N-type Topcon. This will be followed by brief presentations on the performance of Topcon modules under different climate conditions from JinkoSolar's regional technical service heads. So we have Roberto Murgioni from Europe, Mohammed Saady from MENA, Charan from South Asia, and Antonio Ruta from responsible for Latin America. And then we have also afterwards for the webinar invited Shawee Wei from TÜV NORD to speak about the analysis of influences on LCOE by PV modules with different technologies. We will conclude the webinar with a panel discussion with Robby, Leo, and Shawee discussing status and outlook for Topcon. My 5 minutes are over, and I would like to give the word to Robby Peibst to the opening talk. As I mentioned, Robby is the head of emerging solar cell technology at ISFH, leading solar institute in Germany and used by many companies to certify their record cell efficiencies. Robby, the floor is yours.
Okay. Thanks, Michael, for this very kind introduction. Let me share the screen first. So. Can you see my slides? Okay, perfect. Okay. So thanks again for this very kind introduction. It's a great pleasure and honor to be here today and to present my talk, which is entitled The Success Story of Polysilicon Oxide-Based Passivated Contacts. And such a contact scheme is depicted here. It's consisting of a thin interfacial oxide adjacent to the silicon wafer, and it's capped with a doped polycrystalline layer. In this case, it's n-type doped, and typically you also have some indiffusion here, and perhaps some pinholes are formed. And why it's a success story? Because this junction scheme is actually the essential part of the technology, which we, as we will learn in this webinar, will become the successor technology of the PERC technology in the near future. I've listed some co-authors here, but nevertheless, the results presented in the following are obtained within a larger team at ISFH, which you can see here in this photograph. On my first slide, I would like to give some credits to all those who contributed to this success story, actually. And there are many. And it's probably worth to acknowledge first that this junction scheme has been discovered actually by the bipolar junction transistor community already in the 1970s. And quite early, it was adapted already to solar cells in the 1980s. And Jablonowicz et al. Were able to reach, and at this time, outstanding VOC of 720 millivolts on such a device here. But as you can imagine, the efficiency of this device was not as high as today. And then this topic gained momentum again when it was rediscovered, at least for public PV research in 2013 by Fraunhofer ISA and ISFH together. And we both have demonstrated, meanwhile, lab type efficiency records above 26%. But it's clearly a teamwork of so many research institutes and companies all over the world to gain this understanding of the junction scheme that we have today, and to establish also the manufacturing methods, not only for the junction itself, but also for aspects like screen print, contacting, and so on. And eventually it was the achievement of the cell manufacturers such as Jinko and others making this this technology mass production ready at high efficiencies, and as we will learn today, also at competitive costs. Since I'm from a research institute, I would like to spend some words on fundamental aspects of this junction scheme before going to the application. And one fundamental aspect is the physics of the current transport mechanism, which in the name Topcon, as suggested, is the quantum mechanical tunneling through this interfacial oxide between the polysilicon and the crystalline silicon, which you can see here in this TEM image. But already some years ago, we have questioned this picture, whether this is the whole story, and it turns out to be not. There are also some pinholes formed here in the interfacial oxide, which also contributes significantly to the current transport mechanism. This was shown nicely in a recent work of IMEC, as shown here, where they investigated the specific contact resistance of this junction scheme as a function of the measurement temperature, and for different annealed samples, as you can see here. And samples annealed at 700 degrees, this is a rather low temperature for this technology, they show a decrease of the contact resistance upon increasing measurement temperature. This is expected for the tunneling transport. But if you have a higher annealing temperature, then the behavior is opposite. The contact resistance is increasing, as expected for the pinhole mediated transport. And this was shown for all relevant industrial oxide types. And remarkably, this transition from tunneling to pinhole transport occurs at the annealing temperature, which poses the optimum for achieving the highest passivation quality. So in a well-annealed device, you will always have both pinholes and tunneling contributing together. And that's why we are using this term polysilicon and oxide, since it's independent from the current transport mechanism. The second aspect, which is rather fundamental, is of course the efficiency potential of this junction scheme. This can be assessed by different methods and from different perspectives. And one is a very bird's eye view on the selectivity of this junction scheme, which was found to be the highest of all junction schemes reported so far. And you can also try to fabricate your record devices, for example, on lab type level first. And this is what we have done already in 2018, presenting an efficiency of 26.1% on this IBC structure here. Quite recently, we have published a paper showing a roadmap how we can get this technology to efficiencies above 27% with some improvements on the passivation quality, but also on the optics. That means that we are convinced that the efficiency potential of this polysilicon oxide junction is on par with that of the silicon hetero junctions and is above 27% for this IBC structure at least. And now let's come to the industrial implementation of these polysilicon oxide junctions. And here ISFH has developed a very distinct roadmap, which has a starting point from the PERC technology, or PERC plus technology, as we call it, in the bifacial version, where the aluminum is printed as fingers on the rear. And then we would like to combine our background knowledge from for PERC plus with the polysilicon and oxide junctions, but in the first step, keeping the wafer polarity with p-type, and in particular keeping the hole contacts, the selective contacts for hole extractions with the aluminum alloyed P+ contacts. And this should enable both a high efficiency potential, as shown here with these numbers. Those are numerical device simulations for industrial feasible input parameters, with and in combination with a lean process flow, PERC-like process flow, and in particular with a low silver consumption, because at least one polarity is still metallized with aluminum. This can be done either in this IBC version or in this double-side contacted version, which we call polo back junction. And of course, eventually we're also working on long-term concepts, which are perovskite silicon tandem devices. And here we have proposed to use this polysilicon oxide junctions as an interface between the subcells of the crystalline silicon bottom cell and the perovskite top cell, either in a 2-terminal monolithic configuration or in a 3-terminal monolithic configuration. And quite recently, we have also demonstrated the first proof of concept device. But since this webinar is more focused on the short-term concepts, I would like to present you a few results on our technology here. And first, I have to admit that although we would love to keep up with the research R&D records of companies like Jinko and others, this is hardly possible for a research institute, because we do not have this throughput of an industrial pilot line, and we do not have these statistics. So we can hardly keep up with the optimization of the devices, but we can only focus on the demonstration of principal feasibility. And this is what we have done for the polo back junction cell and for the polo IBC cell. For the polo back junction cell, I would say our efficiency so far is fair. The VOC values are already promising, and we think we can increase the efficiency quite soon to higher levels. And recently we have also shown a proof of concept all aluminum cell, which does not only contact the front side with the aluminum grid, but also contacts the polysilicon on the rear with aluminum, which is a very attractive version cost-wise. For the IBC version, we found out that it's not only challenging to develop the cell itself, but also to develop an appropriate measurement technology. We're still struggling with the precise measurement of our fill factor. That's why we can only report on the other parameters and only report this pseudo efficiencies of 25%. Nevertheless, on a designated area, we have a confirmed efficiency of 22.7% from ISFH Caltech, which is also, I would say, fair, not record level. Nevertheless, since this is a Topcon seminar, I raised the question whether some of our innovations can also be transferred to the Topcon cell structure. And the Topcon cell structure, the common one is shown here. It's an N-type wafer with a boron front diffusion and also metallization on front and the rear, which is mainly based on silver for both polarities. And this is, of course, a cost aspect. And but as we've shown for the polo back junction cell, you can use aluminum also as a front grid. You can print narrow lines and you can align them to the LCOE, to the laser contact openings. So this could also be an interesting option for a Topcon cell. Also, the non-alloying aluminum paste applied for the aluminum metallization of the polysilicon on the rear could be an attractive option for the for a Topcon cell. And as we've shown, the aluminum alloyed P+ regions here on the front side, in combination with the N+ polysilicon on the rear side, are capable for high VOC values. So there's no large efficiency limitation. And we have also shown that you can omit the boron diffusion and utilize either the conductivity of the Peter Beaver for a whole conduction to the contacts, or use these P+ regions here as local point emitters. And if you apply all these innovations to a Topcon cell, then it becomes very similar to the record cell recently published by Fraunhofer-ISA on lab type level, or very similar to our polo back junction cell, which is more or less an industrial version of this record cell. And if we can contribute with some of these innovations to the Topcon technology, we would be very happy. With this, I already at the end of my talk, I would like to thank the organizers again for inviting me, all of those who contributed to this work, in particular the team at ISFH and the Leibniz University of Hanover, all partners and the funding sources, and of course, you for your kind attention.
Robby, thanks a lot for this overview. Very promising. Maybe to everyone in the audience, so as I mentioned, we have just 90 minutes, it's pretty packed, but if you have any questions, please note them down in the chat, and the speakers will try to answer them then in a written form. So I think that's the way of communication we can offer. Please use it. Usually it works quite well. So let's continue. The next presentation will be given by the first speaker of Jinko. We will have Leo Cong present their offer, their Topcon offer to the market. And yeah, Leo, the floor is yours.
Okay, can you hear me now? Okay, I will share my screen. And, okay, and I will start now. Hello, everyone. This is Leo Cong from JinkoSolar. Nice to meet you here. And as we all know, the year 2022 is the first year of mass production of N-type technology. You might hear from various platforms that Jinko Tiger new N-type products will be released from 2022. Hence, today we want to give you a more detailed introduction of Tiger new series, the system compatibility, and technical advantages. And first, okay, what we can see now is the product roadmap of Jinko. From 2015 till now, we have been involved in poly, PERC, full cell, half cell, and other technologies, and now Topcon. At the same time, our products are going from small size to large size, from 156 to 158, then 63, 66, and now 182. Model power is steadily improving, and efficiency is keeping setting new records. It can be said that every step we took was decisive and determined. So how does Jinko make its own choices among so many technologies? Why does Jinko decide to be the first company in the market to announce the 10 gigawatt commercial mass production of N-type Topcon at this time point? With such questions, let's continue. And okay, first of all, why do we focus on N-type? The trend of model evolution and development is nothing more than power climbing, which is directly linked to the efficiency of the cell. At present, the efficiency of PERC cell has gradually approached its own efficiency limitation, like 24.5%. In addition to upgrading the cell technology, the power breakthrough can only be achieved from the cell size and the model version, which will undoubtedly bring great pressure to the operation and the maintenance cost and the matching of inverters, while the efficiency limit of N-type Topcon cell is much higher than that of PERC cell, which has an absolute cost performance advantage in the long term. N-type Topcon is expected to be the most promising successor to PERC to become the next generation of core technology leading the PV industry. Also, according to the capacity statistics of market analysis institutions, in the next 2 to 3 years, the capacity of N-type models will increase rapidly, among which Topcon will increase from around 15 gigawatt to over 50 in 1 year from the beginning of 2022. After a whole year's efforts of all manufacturers in reducing costs and increasing efficiency, N-type products are expected to have an even greater growth in 2023, with a total capacity of nearly 120 gigawatt. And at present, N-type cell technology mainly includes Topcon, HJT, and IBC. Among them, Topcon and HJT are the focus of the current N-type technology route. By the way, HJT is also called HIT. Both of them is correct. As you know, Jinko is the first batch of model manufacturers that try to use N-type technology. So you might heard that the name like HOT 1.0 and HOT 2.0. We can match HOT 1.0 with PERC technology in the picture, and we use at the beginning, while 2.0 with Topcon that we use now. And the next page, I briefly list the structure of these two types of N-type cells. They are more complex than traditional PERC cells, but we just need to focus on the red layer. In short, Topcon and HJT, they achieve power improvement through passivation. But the difference between them is that Topcon through tunneling oxide layer, while HJT through deposition of amorphous silicon film, which leads to the difference of their respective processes, resulting in the difference of their commercial costs. This figure mainly comes from two aspects. Firstly, HJT as a publicity point has a simpler production process, which is incompatible with the existing production line as a cost. And the direct result is the increase of equipment cost of 240 to 400 million yuan per gigawatt. N-type Topcon technology, as I mentioned above, is under mass production process now. It is in a rapid development stage, which means that innovative solutions are constantly proposed in the industry. We have been cooperating with professional cell equipment manufacturers to optimize the manufacturing process of Topcon while improving cell efficiency. Secondly, there is a gap in the consumption of cell pulp. According to the current data, the consumption of cell pulp of HJT cell is about twice that of Topcon, and this ratio will not be leveled in the short term. It is impossible to deny that, HJT is an excellent technology, but the commercial use and the promotion of this technology has been prematurely advocated and accelerated, in my opinion. Models are relatively downstream products in the industrial chain, and the difference of 0.3 yuan per watt is absolutely unacceptable on a large scale. This is why Jinko and other mainstream manufacturers will still focus more on Topcon technology. In my opinion, it is still premature for HJT to be commercially or widely available for at least 3 to 5 years. And this page, this is a brief introduction of our TaiyangNews N-type Topcon models. This series consists of 78 monofacial and bifacial models, 72 monofacial and bifacial models, and then 60 and 54 monofacial products, covering the demands of utility, industrial, and commercial, household rooftop, and other scenarios. Overall, the power of N-type models will be about 15 watts higher than that of P-type. And as we can see, the characteristics of high power and high efficiency of 78 monofacial products bring optimal LCOE to some utility projects. The low voltage, flexible string setting, moderate size make the 72 monofacial products widely applicable to different power stations. Besides, for DG market, we have 60 and 54 monofacial products, which can be compatible with residential roofing and CNI. For some regions where the product appearance is more demanding, we can also provide the option of all black models. And I believe actually our customers, they are more interested in the specific advantages of our products. First of all, in terms of quality assurance, N-type cells power degradation can be significantly optimized compared with the traditional PERC cells due to the different doping technology, reaching the level of first year 1% and the linear decline of 0.4%. Whether from the first year or long-term power degradation, there will be a more significant advantages for N-type Topcon technology. And more technical side, LID, a loss in the boron-doped P-type silicon solar cell efficiency is observed during initial light soaking process. Boron oxide complex activated by seed injection of illumination was indicated the root cause, since boron oxide complex capture bark a minority electron as recombination center. Even hydro generation cannot passivated boron oxide complex deflects totally. I mean, the N-type cell use phosphorus doped process, no boron oxide related LID, and also no degradation by initial illumination. And secondly, in terms of model temperature coefficient, Jinko 182 N-type models can achieve an optimized temperature coefficient of -0.3% and increase the average power by about 0.75%. At the same time, the TaiyangNews series models operate at an average temperature of more than 1 degree centigrade lower than the P-type of some specification. Combined, power generation can be increased by up to 2% in high temperature areas. As we all know, with the continuous increase in the cell size, the model current will continue to rise, and under the premise of large current model, this advantage of temperature coefficient will continue to expand. And besides, the bifacial factor is also improved. We should be familiar that the bifacial factor of the traditional PERC model is about 70%, while the N-type cell using Topcon technology has the highest bifacial factor of 85%, as shown in the figure, using P-type monofacial model of the sample specification as a baseline. P-type bifacial models can provide a 9.45% generation gain, while N-type models can provide an 11.48% generation increase with 85% bifacial factor. Under this price, our TaiyangNews series models can deliver a power generation gain of about 2.03%. In conclusion, lower LETID and improved LID to lower than 0.5%, better temperature coefficients, higher bifacial factor, and significantly optimizing power generation capacity. Under conventional weather and surface reflectivity, the Jinko TaiyangNews series models can deliver an average generation gain of more than 3%. Of course, the above theoretical analysis also has the test data support. The data shows the model data comparison in Haining, China, with the same specification P-type models as a baseline. P-type bifacial model can bring the power gain of 9.7%, and the Jinko N-type Topcon models can bring 12.7% power gain, increase of 3%, which is consistent with our theoretical analysis. And from the economic point of view, TaiyangNews directly reduces EPC costs with its higher power generation efficiency and better size. For utility projects, if the total length of the tracker is fixed usually 100 meters, I mean, the width of the 182 TaiyangNews and the 210 models is different, which directly affects the difference in the number of strings, whether from the comparison of previous 3-string and 2-string, or the existing 4-string 182 and 3-string 210, the TaiyangNews is far ahead in terms of total power carried by a single stand. At the same time, the improvement of model efficiency also reduces the operation and maintenance cost. Finally, the high power generation gain through the whole life period for TaiyangNews LCOE is greatly reduced. We did this analysis under 200 megawatt AC power station in Inner Mongolia and use our 600 and 5 watt N-type model to versus 660 P-type models as control group. What we should focus is that our TaiyangNews model could cover more megawatt in single tracker, which brings 1.18% false cost decrease. Besides, take the power gain into consideration, the LCOE data of our TaiyangNews models also have significant advantages. And as you can see, the TaiyangNews series still use 182mm cells, which are consistent with Tiger Pro products and have a natural advantage in terms of bracket compatibility. After long-term market feedback and customer satisfaction service, Jinko's Tiger Pro products are reliable in terms of mechanical strength and installation. Besides, in terms of inverter compatibility, Jinko has also conducted a complete preliminary market research. As of Q1 2022, the majority of inverter products can be adapted to Jinko's TaiyangNews high current models. Starting from Q1 2022, Jinko will gradually release the TaiyangNews 182 N-type Topcon production capacity, which is expected to reach 10 gigawatts for the full year. At present, Jinko is actively seeking cooperation with third-party testing institutions. We have designed solutions with TÜV NORD, RAIN, SGS, CGC, and CPVT, and have planned and implemented dozens of outdoor or test projects for TaiyangNews N-type Topcon models in various application scenarios and weather conditions all over the world. Jinko, as a first-tier PV model manufacturer, is confident to be the leader in the industry's N-type technology upgrade and will continue to provide customers with the best quality PV solutions and model products. Thank you.
Thanks, Leo. Impressive product. Again, if there are any questions, please ask them in the chat, and Leo or someone from Jinko will answer them. Let's continue with the next session. So we have now half an hour where we will give where we have different head of services talk about Topcon module performances around the world. So let's start first with Europe, I believe. We will have Roberto Murgioni, Head of Technical Services and Product Management at Jinko, talking about high efficiency Topcon solar modules for rooftop projects. Roberto, the floor is yours.
Yes, thank you very much. Hello everyone. It's a pleasure to be here. Yes, today I will focus my presentation on the perfect fit of this technology applied to the rooftop projects, which means basically residential and commercial industrial markets. I'm going to share my screen right now. So here we are. So let's start by analyzing what is the market trend. Okay. And yes, now you see. The distribution market installed capacity forecast we have analyzed is actually becoming much more important than before. Here by here, you see the analysis and you see how the residential, the small commercial are becoming a very important sector in the PV business, specifically in Europe. And that's why we wanted to design and offer to such a high demanding market a product which is what we call a perfect fit for residential rooftop. You know, residential rooftop is an investment which is called small, but it's also, you know, a very high requiring market in terms of aesthetic designs, in terms of power density, and in terms of quality and warranties. Same discussion is for commercial and industrials. I mean, both markets, they have specifically limitations in terms of surface, and that's why we really wanted to apply this superior technology to our portfolio in order to offer higher efficiency, so to increase the power that they can install in their rooftops. Not only, also to offer a premium technology, which is called all black design, which will be combined to this new slim multi-busbar technology, in order to also offer a premium in terms of aesthetics, in terms of appearance. Starting from the dimensional point of view, we wanted to offer something that is portable, easy to install, and obviously when operating at in a rooftop, you have to always take in consideration of the safety rules. So by designing a PV module, which is the Tiger Neo 415 watt peak, we took in consideration all these inputs, and we are now able to offer the Tiger Neo to the residential market, to the commercial, in dimension which is 1.7 per 1.1. And as you can see, we call it human focused design because it's basically very convenient for the installers to work with such a low weight, which is 22 kilograms, but also we call it very portable for transporting and for moving between the different operations at high conditions. So, and not only, but by increasing the efficiency and the power, we are also able to offer to our final customers a superior technology in terms of power density, which means that by installing the models in your rooftop, you can increase your power, which means your energy at the end of the year. We perfectly know that we have different obstacles when designing PV plants in a rooftop, which can be, I mean, a combination of different, also starting from the tilt and from the different trees, obstacle you can have. And by using this Topcon Tiger Neo, you can increase again the power and reduce the area that you have to occupy for your PV plants. To be more specific and having this concept, different comparisons, it's perfectly understandable from this picture that from a standard rooftop, you can easily fit your models plus increase your power output. So this is a simple comparison of different designings, but it gives you a complete picture on how the new dimensions are perfectly matching the requirements of this market. So having an overview on our portfolio, we are speaking about our new product, which is Tiger Neo 54 cells configuration. And it will be monofacial with a 54 cells configuration. And the power range right now, according to the roadmap, it's between 410 and 420 watt peak. But let's now get into the real feature of this product, and let's check what we can offer to the market. So this innovation product and technology will be equipped with silver frame with a silver panel, but also can be equipped with a black frame in case of different options. And the product warranty for the standard product will be 15 years, which is already superior compared to the standard market. And not only, one of the most important features of this technology is definitely the temperature coefficient, which is -0.30%. which is better compared to the minus 0.35% of P-type, and it's very important for rooftop projects. Sometimes we forget that by installing the models in a rooftop, we have limitation in high circulation. So we have a higher impact of the temperature on this type of installations. But by offering a lower temperature coefficient, we can extremely improve the response of this product to the different environment conditions, to the different temperature. And this is very important because this feature will definitely going to increase your energy output. And nevertheless, here we have our premium product, which is our Tiger Neo 54 all black. And we are very happy to offer this premium product to the market, which will come definitely with a premium product warranty, which is 25 years. I would like to highlight this number, 25 years, which is on top of the category. So we will offer definitely a premium product on quality, on warranty, and on efficiency. So we have a highest efficiency of 21.25%, one of the best temperature coefficients that we can offer in the market, with a maximum power of 415 watt peak right now. And this is a quite important, introduction because it's a unique product, whole black, with a perfect fit in terms of energy output and dimensions. Having a look to the advanced warranty we can offer, so which will be 15 years for the standard product and 25 years for the whole black technology, we will offer also, of course, as Leo said, the 30 years power warranty, which is definitely again superior of P-type, much more superior. The green light is the green area is the area that you will gain as an energy output. So the very first year, the degradation will be less than 1%, and the linear degradation will decrease to minus 0.4%, which is a very huge step towards efficiency and energy output. In terms of power roadmap, we have right now this product with a range of 410, 420, and by the end of the year, we will increase one power class. And that's mainly the biggest innovation that we can offer in residential market. It's very important to highlight the warranty that we can offer. From the European perspective, we consider this product as a key product for our strategy. Thank you all. I try to keep it short, and yeah, we can go on.
Thanks, Roberto. Great to see how Topcon is a wonderful product for rooftop applications, and great to see the long warranties you're offering. So we continue now, and with Mohammed Saady, Head of Technical Services at JinkoSolar in MENA, and Mohammed will focus on low temperature coefficient to maximize energy generation using Topcon modules. Mohammed, the floor is yours.
Hi, Michael. How are you?
All good. How are you?
It's a pleasure. Fine, thank you. It's a pleasure to be presenting with you, and also pleasure to be presenting with my colleagues at Jinko in different regions. We've been away for too long, so it's the first time that we present together. So it's always a pleasure. Please apologize for the technical issue that prevented my computer today. Decided not to detect the camera, so I hope it's okay. I will start the topic today because today's topic for me is very, very sincere actually, and I'm representing force in Middle East and North Africa. So when we talk about the temperature effect, we are talking about very serious effect we take into consideration in our utility projects and in our region. And it's very exciting that now we have a product that can really minimize the effect or negative effect of the high temperatures in the region. Before we go into more details, I just want to give an overview of the MENA region now, Middle East and North Africa, one of the hottest and most emerging markets now globally. And of course, as you see in the map, that in terms of potential, we have the highest potential for solar implementation. But of course, because we are located on the Sun Belt area and we have very high irradiances. But of course, unfortunately, you cannot get the benefits only. So you have to deal with the side effects, I would say, or the obstacles, which is the high temperature that we are facing. In MENA, actually, the weather is very harsh. You have high humidity, you have high temperatures, you have very heavy soiling effect. So although considering all these obstacles, if you go and see the lowest LCOEs globally, you will find almost all of the projects are located in Middle East and North Africa. Mainly now the two most active areas are Saudi Arabia and UAE. So it's very unique that with all these obstacles that our region continue to break the record for the LCOE, because actually everybody here, every stakeholders are optimizing each value and parameter in the LCOE to the maximum in order to lower and to be a competitive, especially talking of course about we are living many of the countries in the UAE are oiled, or in MENA, sorry, are oil-based countries. So they're heavy subsidiaries for oil. But with all this considered, solar energy has proven to its role in leading the transition to renewable energy. And if we have a look at how the temperature coefficient especially has improved during the years, a few years ago, when the polycrystalline was the mainstream module technology, we would talk about mainstream temperature coefficient of -40. Then with mono, replace the poly, it has a slightly better temperature coefficient. The mono PERC came and shifted the market completely into mono, and this actually led to polycrystalline to be phased out of the market, at least in the top, I would say, 5 or 6 companies, tier 1 globally. And the half-cut came, and also it was another solution for the problem. Half-cut technology has proven to be a very good technology to reduce the cell temperature. But you will see the development is, slightly better getting every year. And now when we see the mainstream temperature coefficient for the mono PERC suppliers, and including Jinko, of course, with Tiger Pro modules, you will see the mainstream temperature coefficient value is 0.35. So now having a mainstream company like Jinko offering a very improved temperature coefficient from 0.35 to 0.30, which is improvement 30% compared to 0.35 in 1 year only. This is an astonishing improvement, and it will really shift the market and the understanding the performance of PV modules in high temperatures. So actually, we did a very initial estimation for a project, 200 megawatt in Saudi Arabia, and we discovered that only this value alone, shifting from 0.35 to 0.30, will reduce the LCOE at least by 1%. So we all know that LCOE has hundreds of factors contributing to LCOE. So only having one factor contribute to affect 1 or 2% of reducing the LCOE, that means that this factor is really, really important in our region. And of course, why it's important for our region, because the higher the temperature, the more the difference will be obvious. So if we take an example of 550 watt modules at STC, and we follow the degradation under the mono PERC technology 0.35, you will see at a cell level of 55 it will be 492 instead of 550, and it will keep reducing until at 85 degrees cell temperature, it will reach 434. Now, if you have the optimized and new temperature coefficient offered in Tiger Neo, which also compared to other N-type Topcon technology is considered the best in the Topcon technologies. So we will see the degradation actually is considerably better, and this will even show at higher temperatures. So if we take a temperature of 65 degrees, for example, you will find that the difference is 2%. So the Tiger Neo will give 2% additional watt power compared to mono-PERC modules in the same weather conditions or temperature conditions. And of course, maybe in some other areas in Northern Europe or Northern America, in Japan, maybe the temperature coefficient is not significant, but where maybe the cell temperature can be something between 35 to 45. But when we talk about Middle East and North Africa, we're talking about cell temperature reaching 65 and even in some cases 75 and 80. So it's significant that you can have at least 2% of additional watt when you have only one factor contributing to this huge improvement in the performance. This is not even, we did not even consider the bifacial factor, the degradation, the low light performance. We are only talking about one factor only contributing to this. So that's why for MENA, with our in the market, because we started talk about Topcon for the last 2 months in the market, and we have seen the market reception is way positive than we have ever imagined because of the solutions it can give to the utility scale market in the region. So of course, having improved temperature coefficient is not only about the performance or temperature coefficient itself, but also it will give you, it will reduce the cell temperature, so you will have more stable performance. You will have less risk of having hotspots, and of course, reducing in general the module temperature will also have an impact on the structure itself. It will also have contribute to reduce the structure temperature. So overall, it has positive impacts, especially on the performance of the modules. And for MENA region, this is, the most important factor when we have a consider any modules. Temperature coefficient is one of the values that everybody is really paying attention to. So it's very exciting that Jinko is leading the market into shifting to Topcon technology as a mainstream technology in the market with the biggest capacity in the market. And we are looking forward really to see the market follow Jinko's lead. Back to you, Michael. Thank you so much for your time.
Wonderful, Mohammed. Impressive slide showing actually how the temperature coefficient, what's the impact on the output of the module. Let's continue. We're running a little bit behind. In the end, we want to stay within our 19 minutes. Next speaker is Saady, and he will speak about degradation issues, which are not an issue for Topcon. Please, Saady, go ahead.
Hi, Michael. Hello, everyone. Very good morning, good afternoon, good evening. Just a moment. Let me just share my screen. Great.
Just click on presentation mode. Wonderful.
So specific to our region, if you just try to see, anyway, most of our colleagues from Jinko have clearly explained specific to what kind of benefits that generally is being portrayed with Topcon kind of technology when compared with other existing PERC kind of technologies. But going forward, specific to our region, if we just try to say for Indian market kind of thing, where comparing the existing 1i2 wafer size modules, which is coming with PERC kind of technology on P-type versus Topcon and HAT, we can see these all are the benefits, which is what is happening with Topcon kind of thing. Let me just try to be more specific on the aspects of degradation. If we just try to look at this particular PERC technology, the P-type kind of technology, which initially started with 156.75 wafer size kind of thing. Before that, it was standing at a kind of degradation factor not less than 3% per year as a kind of first year degradation, which is having all kinds of degradation limits, which is specific to light inducer degradation, hydrogen degradation, and metal inducer degradation, all degradation factors including together. But later on, with the kind of development, advanced mechanisms which is being imposed on the doping activities, this value has been reduced to 2.5% or 2% with this particular PERC kind of technology. But if we just try to look at this particular Topcon, which is the second generation technology of N-type, this has now came down to 1%, not even 1%. What we can see is that N-type is completely in a kind of semi-intrinsic semiconductor. So specific to semi-intrinsic semiconductor, definitely the kind of impurities are going to be completely nullified, which is why all kinds of astronomical or spacecraft applications generally try to go with N-type kind of technologies. And within these kind of technologies, if we just try to see the kind of degradation pattern, it has to stand at 0.1% to 0.2% as max, which is why if we just try to see if you're trying to go for a kind of mass production in gigawatt kind of scale, the value of this particular first year degradation or the light inducer degradation can stand at around like 0.5 to 0.7% as max. So considering these particular aspects, we promoted and we provided our product specific to Topcon technology of which is coming with 1i2 mm wafer size with 72 cell or 78 cell is going to stand at 1% on paper. But eventually, if we just try to test these particular modules in laboratory, definitely the LID value is going to stand not less than 0.4% or 0.5%, and first year degradation compiling all other degradation aspects is not going to cross beyond 0.7%. So this is what is going to happen with the first year degradation when compared with Topcon versus PERC kind of technology. Similarly, the other N-type technology, which is coming in the second generation of N-type itself, can be HAT or HIT, which is again standing at 2% as a kind of first year generation, which is more specific to the P-type kind of technology optimization, which is what is there. And on the year-on-year degradation, which is what is called as linear degradation, is standing at 0.45%. So comparing these particular aspects, what exactly is going to happen with these particular degradation aspects? I'll just try to show you with a case study. This is one typical one of the spectator was asking specific to how reliable this particular N-type technology is when compared to P-type kind of PERC technology. This is a kind of extended reliability testing specific to thermal cycle, the damp, heat, humidity, freeze. If we just try to observe clearly on the aspects of thermal cycle or humidity freeze or UV, on the aspects of reliability testing, whether that is happening with one-time IC or two-time IC, what we can observe over here is that the P-type values, whatever is there, is always higher than N-type value, which is clearly specifying that enhanced reliability of these particular N-type technologies or the Topcon technology, which is the second generation technology in N-type, is always more reliable when compared with P-type kind of thing. So which is why these particular Topcon kind of technologies are not just going to be limited only for DG kind of markets or C&A kind of markets, but yes, this can be spread over to utility scale kind of segments as well, which is why we are also trying to promote this particular products in Indian market, more specifically, and in South Asian markets and Central Asia market. These kind of Tiger Neo kind of technology products are going to rule the market morely on not just limiting only to the power density, but yes, even on the energy density. The reason is that this particular degradation factors, whatever is happening specific to 1% of committed value of first year degradation and 0.4% of year-on-year degradation definitely is going to change your NPV analysis or your LCOE benefit analysis. So this is one typical comparison analysis which we tried in doing, comparing the monofacial and bifacial, comparing again with P versus N. So if we just try to see, this particular location is from Barmer, Rajasthan, within India. Taking this particular project as a reference, by just taking all different kinds of modules, which is what is available in the industry, specific to our modules only, where we try to provide Tiger 78, which is a tiling ribbon, which generally comes with 163 mm size of wafer size. And similarly with 180 mm wafer size, which is again there with a P-type 540 watt peak kind of thing. So if these particular figures are the specific energy yield values, which is going to be there for kilowatt hours per kilowatt peak per year. By comparing P-type versus N-type, we always can see that the benefit, whichever is happening with N-type, with bifacial is always crossing beyond 3% kind of values. So that is one key takeaway, wherein which your NPV analysis or within your LCOE model, if you just try to run this particular aspects, it will provide a benefit of not less than 2 cents to 3 cents kind of benefit. So in India, if you just try to see this, this is completely making much more sense, even on the utility scale segment, not just limiting these particular N-type products to niche market on DG kind of segments or rooftop kind of segments, but yes, on these kind of utility scale segments with bifacial kind of modules and going with the kind of tracker plus bifacial plus string inverter or central inverter is completely going to change your FM financial model like anything. And this is one typical chart which we tried in doing specific to this particular Tiger or 72HC VDVP kind of module, which means normal PERC kind of technology. We can see that 1763 is a kilowatt hours per kilowatt peak per annum, which is the specific energy yield, which has been observed with P-type kind of technology. And the same with N-type, with the same similar wafer size of 180 mm wafer size. What we can see here is 1817. So if we just try to see the capacity utilization factor benefit, where exactly with 40% overloading, where we can see that with P-type, if it is standing at 28.18%, the same thing with N-type, it is standing at 29%. Why is this happening? Just because that the limited or the reduced value of first year degradation and year-on-year degradation is also going to benefit the entire value of at the end of 30th year. We can see that N-type technology is standing at a CUF of 25.11%, whereas the same with PERC technology is standing at 24.36%. So this is one key takeaway specific to new kind of technology aspects. And if you just try to see what exactly is happening on the other fronts, which is there on the NPV analysis, which is like if we just try to see before driving down to LCOE analysis within your financial model, there are three different aspects. One is the capex, second is the opex, and the third most important factor is the specific energy yield. Only specific to specific energy yield, what can be benefited and what can be benefited from capex. So from capex, we very well know that the power class of the module or the BOS savings is a kind of complete benefit which will add up value in your capex calculations. And similarly, the power class values with the increased power class, the amount of water which is what is required for cleaning the modules, or the number of man hours which is what is required for that particular cleaning mechanism is going to be reduced in the OPEX calculations. Similarly, within the energy yield, this particular NPV analysis is one typical concept specific to reducing your LCOE value. So if we just try to see only with the addition of these particular energy yield values, if we just try to compare and see what exactly is happening between 182 mm Tiger Neo series of 78 module versus all other typical P-type modules, if we just try to see that with the existing Tiger Neo series, comparing this with 182 mm bifacial module or monofacial module, if you just try to see the existing 540 watt peak module, it is going to have a kind of delta of not less than 3.9 cents specific to Indian conditions. And if you just try to compare the same module with a bifacial module of 540 watt peak kind of thing, 1.7 cents is a kind of direct benefit. It's a kind of key benefit, which is what is happening just comparing these particular Neo products versus the existing PERC kind of technology. And the same thing if we just try to compare with 78 cell of bifacial module, it is standing at 1.6 cents. This is just NPV analysis benefit, which means the energy gain benefit itself is standing at these particular values. The moment if we just try to go with the entire LCOE analysis, what exactly is going to happen? it is going to stand not less than 2 to 2.4 cents to 3.2 cents as a kind of benefit which can happen on the entire LCOE analysis by just comparing PERC versus Topcon kind of technology. With this, I end my presentation just due to limited point of time. Thanks, Michael. Back to you.
Thanks, Sai. Very interesting again. So let's, we're a little bit late, continue and move across the ocean to Latin America. Next speaker is Antonio Ruta, Head of Technical Service, JinkoSolar LATAM, and in Italy, in Europe. Antonio will talk about LCOEs, a crucial topic in project planning. Antonio, the floor is yours.
Thanks a lot. Thanks for this opportunity. I'm going to say thanks to most of my colleagues that introduced most of my concepts. So I just wrap up and do some consideration. Oh, sorry, I don't know if you see my presentation. It's okay? Yes, thanks a lot. So TaiyangNews is fit very well the utility scale application, and thinking about our region, I will say that our region is 100% using bifacial models. And TaiyangNews, as was explained before, leads to more energy power density. No? So practically the fact that it's more efficient it leads to more power from the same area, or we use less area to reach the power that we have in mind. Also, our region, like the MENA region, it's very hot, as a very hot environment. If you remember the map of Mohammed, some region like Brazil have the same characteristic, I mean, hot environment with high radiation. And the low temperature coefficient helps a lot in order to get more energy. And the higher bifacial factor, as we explained before, it's increasing the energy here and help in order to, let's say, to have better results. Practically, these are the two models that we have been offering to our market that are really, let's say, happy and let's say interested in going to this kind of models because they believe that it's well also our region. Moreover, we, as we see before, we have the demonstration project that we are running shows a certain consistency between the real data and the simulation. So practically simulation, let me say, can give the right idea how much will be the production and particularly the benefit of the TaiyangNews in considering the project. Also, BOS calculation must consider also the carbon size because we are speaking about models that have a current limited to less than 50 amps. This is bringing a benefit in the total design of the system in terms of safety and the current design. I mean, we can lead to less current loss because of lower current. And moreover, because we are in very high hot environment, like sometimes in Brazil, we have minimum 2 degrees, even more than 10 degrees, we can put more models per string. So still having advantage on this sense. The real LLD degradation is lower than 0.5%. We award 1%, but we see that our R&D show that this value is less. And moreover, we have finally that our TaiyangNews 72 cell bifacial is one of the most power density per container. And it is very important because it's another parameter that is affecting the LCOE. You know? So practically, let's assume that we do a simulation case study with our biggest market, where both utility scale and the DG market are well exploited. So, and we see a state in the power state that is one of the most high-gauge radiance and a good value. It also have also good over radiance problem as effective also over radiance. So the models really even perform more than a standard test condition. Let's consider also a total power of 125 megawatt. Of course, we are using what is the mainstream in our region. I mean, tracker, monoaxial, central inverter, sometimes also string inverter, but in this case, we consider a central inverter. This is simulation. ISDCAC ratio 1.2, and the base case is the 182 target of 5, that is a good model, but actually that has great success in our region, where the specific production according to PV system is 2 to kilowatt hour per year. So in terms of efficiency, of course, if we consider the same dimension, Tiger Neo allows 15 watt peak more in same dimension. So practically we can have a great advantage, as we say, in terms of number of modules, or in case of ground needed, because we can save ground. In our case, we can put more models, so practically we can add more power density, or even in the ground that we are considering. String length is the same, thanks to the fact that we have a minimum temperature degree of 15 degrees, we can achieve 29 models per string. The energy yield, as our colleague explained, is more. We see that according to the bed that we consider an average of 20%. We have more than 2% energy yield compared to P-type. And of course, we have also logistic optimization in terms of power, because we can save a total energy. And nowadays, this is another cost that we need to consider in terms of COE, because this is affecting the BOS cost that any EPC must consider in their calculation. Of course, this is if we consider the comparison between P-type and N-type with the same dimension, I mean 72 cells. But if we consider a larger cell, we have other advantage, like for example, less number of modules. We still keep the same principle of lower current, because even the larger models over 600 per cell, 605 watt peak, it's bifacial at the same time, has similar current, like a short circuit current, and practically the energy yield is more or less the same. So practically, if we consider also comparing our models, Tiger Neo, with our bigger models, the larger models that are nowadays in the market, we have the same advantage in terms of energy yield and efficiency. We need to consider, do not forget the linear degradation, the concept that has been emphasized before by my colleague, that if we consider that the gap in production, the fact that we have less degradation, the energy yield gap will increase year by year. So practically we will have at the end of the year, at the end of the days, 4% during in terms of production, because our models degrade less. Overall, total energy will be 3% more. And all Tiger Neo is consistent with the principle of low current. This is because of the size of the cell. So practically we do, and this is avoid a lot of headache to the designer, especially when they design the safety part of the design of the PV system. And one of the other benefit of our Tiger Neo, because it's consistent with the mechanical format. So the width that is 1134 millimeter leads to less longer string compared to other cells. So this is fit to better, let me say, fit with the existing and the tracker, because of the combination, the compatibility is better. So practically, simulation and all the parameters on the discussion that we have done till now confirm the premium value of the Tiger Neo, because these parameters are lowering the LCOE. Of course, now I'm going to leave the floor to Shawee Wei, the TÜV NORD, that explain better all the parameters that affect the LCOE. But as you can see, with my discussion and the discussion of my colleague before, we have several factors that affect the LCOE, and we believe that in our region, especially also in LATAM, these models is the best fit for the needs of every provider or IPP. Thanks for your time. We have a question.
Thanks, Antonio, for showing Topcon's advantages also in Latin America. So we're running a little late still. Shawee, please be quick. And we're very much looking forward to have now Shawee Wei's presentation on LCOE. It's always good to have an independent testing institution talk, and we're very happy to have Shawee Yu from TÜV NORD with us. The floor is yours.
Thanks, Michael. Let me share my screen. Everybody can hear me clearly, right? And now the presentation. Okay, good. So hello, everybody. This is Shawee from TÜV NORD OBS Renewable. So today I would like to share the topic about analysis of the influences on LCOE by PV modules with different technologies. So first of all, about TÜV NORD, we are a world-leading technical service provider who do technical, digital, and due diligence throughout 150 years. So we have 4 main brands, which are TÜV NORD for the certification, testing, inspection, DMT for natural resources. We also have the auto technology for the aerospace, and have the TÜV IT for the information technology. So overall, we have do the system performance evaluation over 55 gigawatt with 3,000 certificates issued around the world with 150 global branches. So to the background of today's topic, so every year, different kind of researching institute would publish all kinds of indications or forecasts on the installation of the PVs, and we can see the trend even with the pandemic situation that every researching institute are indicating the a good and a great increment on the installation of the PV utility. And we can see there are lots of increment in China, in Europe, and also in the North America. And for all these installations, there is one key factor, which is LCOE, or called levelized cost of energy. So basically is the life cycle cost, which is the cost during the overall system operation time, to be divided by the lifetime energy production. That is all the energy you can gain during the overall system operating time. And here is the equivalent, and there are some parameters are relatively similar to different projects, but there are also lots of variables, such as the total investment capital, the land fee over the years, the tax over the years, the operation and the maintenance fee over the years, as well as all the energies you can get over the years. So all these variables would give you different LCOEs, higher or lower, and of course people are looking for a lower LCOE. So here is the data or the indication from DNV saying that the LCOE is still decreasing in the upcoming years. As I think we all know that particularly in 2021, the raw materials the price for them are increasing seriously, and which will cause the LCOE a little bit higher for 2021. But even in this situation, even in this pandemic situation, that the LCOE will still be going downward, which helps to enlarge the investment or the utilization of the PV energy. So to achieve a lower LCOE, there are some emerging technologies that will help on this matter. So currently there are two roadmaps or two different technologies already being introduced previously. One is the Topcon, the other is the SJT. For Topcon, it has great advantage, which that it is fully compatible with current PERC production line, and the theoretically efficiency is higher than SJT. So this is popular, and as a third party, we can see the trend in our daily certification and testing work that more and more modules are using the Topcon technologies. So also by the indication of trend force that the N-type cell production and the Topcon cell production are increasing or blooming fast. Starting from 2022, the ratio of the N-type cell will go increasing from 4.7% to 11.1%. And you can see on the right that the Topcon will also grow. So here we make two simulations on two different locations, different altitude, different mean ambient temperature to simulate two different scenarios. One is in Spain, the other is in China, the north part of China, Qinghai province. So we unified the DC capacity of these two systems, 120 megawatt. We use different type of mounting system. One is the single axis tracker system with 2 PV modules. The other is the one with 1 PV module, and we do the simulations. So let's look at the LCOE evaluation for the Spain. As a background, we have two different cases at this location in Spain. This is the basic information of these two projects. And there are several key factors I have been marked in green that you can see on the screen. First of all is the temperature coefficient of power, which the one used Jinko's module has lower temperature coefficient because of utilization of the N-type and Topcon. So also the efficiency is higher, the bifaciality coefficient is also higher. And another advantage is that the initial degradation at the first year is only 1% compared to the other one that has 2%. So that's the main differences here. And we do the simulation using Peibst to get all the images that for the first year, and using the calculation from the data sheet that every year it will decrease by 1.4%, 1.8%, etc. Until the 30th years. Then we got this comparison or the overall energy generated from the result. Say that with the utilization of Jinko's PERC module compared to the other one, that the energy they got is 3% higher. So here we find some reasons, and also that's the advantage of the modules that we introduced just now. Say that the module has a higher efficiency, a higher bifaciality coefficient, with a better temperature coefficient and the low power degradation every year, which all helps in getting a higher energy generation during its life cycle. So here we can also see and analyze on the capex of the project. So we can see that if we assume that the cost of the module inverter or the inverter, the fee for development and design and some other irrelevant cost with the module types are the same. But we can also see there are some major differences because of the different two types of the PV module. Say that the number of the trackers we use are different. The electrical system are different because for Jinko's, it's the current is lower, so we only need to use the cable with 4 millimeters 4 square millimeter, while for the other one, we have to use with higher current, it has to be using a 6 square millimeter cable, which costs higher in the cost, and due to the size and weight, so the installation cost will be different, and the land lease cost will also be different. So based on all these different factors, we can see that the overall total investment are different, and Jinko's is lower. So with this separate items for the tracker, for the electrical system, for installation, and for the land lease, the difference are listed here: 5.52%, 0.30%, 2.72%, and 2.30%. So these are the major differences here. And overall, when we calculate the LCOE for these 2 different projects, we can see that JinkoSolar, the LCOE for the plant using JinkoSolar's module is 58% lower than the other one. Now we look for the project in China. So here are some similar cases. We put 3 simulations using 3 different kind of modules. One is the JinkoSolar's with 72 188 millimeter cell. The other 2 using 210 millimeter cells, with same advantage in the temperature coefficiency, module efficiency, bifaciality, and degradations. So we do the same calculation here, and we got a similar result or similar conclusion that with all these advantages, the power generation is much higher, at least 3% higher, and the investment would be lower than the others. So you can see, especially in the electrical system, that different type of PV modules or plants have much differences in this part, especially. So the conclusion is that the one using JinkoSolar's module, the N-type module, has at around 4% lower LCOE than the other 2s. So let's draw to the conclusion that from the result of this analysis, so with the unified DC site capacity, land availability, etc. So Jinko's N-type products have great advantage in terms of the cost per kilowatt hour, because that the module's efficiency are higher, so it can greatly reduce the initial investment cost, and it can save the use of the plant and thereby reducing the annual land lease cost. And the module have a lower power degradation and higher bifaciality coefficient, which also helps you to generate more power during the life cycle. So this is a great help with the N-type Topcon technology here. So that's all for my presentation. Thank you all for the attention. And if you have questions, you can put in the chat or send emails to me. I'm happy to answer to you. Thank you.
Thanks, Shawee. That was a rapid and great impact. I think there is already a question in the chat. You might want to address that. So let's have a very brief panels. So Robby, Leo, Shawee. I think I will first ask a few questions to Robby, then to Leo and to Shawee, and then we wrap that up so that we can spend maybe 5, 6, 7 minutes on that so that we are not too much delayed. Robby, let's talk about efficiencies. It's great that you've shown actually what's possible, what's happening in the labs also, and we saw also the theoretical efficiencies are pretty high, depending on what you do. If you add back contacts, IBC, or if you go to tandems, you can go even to 30%. And if you're not so sophisticated, you're already at 27 around 27%. So what's the time scale, the timeline actually to reach that levels from your perspective as a researcher?
Well, are you referring to industrial median efficiencies or to?
No, let's stay first maybe on the R&D level, and then we can.
On the R&D level, I think that the 27% should be achievable in this or next year, either in our lab or at competitors' lab. I'm very confident, and also for the tandem efficiencies, they are continuously rising. So I think 30% will be surpassed this year for the tandem efficiencies.
Okay, and if you look at commercial levels, what do you think there? I think there's always quite a gap.
Yes, well, I think for the Topcon technology as presented today, we have already seen efficiency above 25% on R&D records for industrial cells, but the median efficiency is a bit below. It will also come at this level, I think, in 1 or 2 years. I would think median production efficiencies close to 25% or even above are feasible, and everything above this will require perhaps some more modifications and will perhaps take some time longer. So I think 27% or 26% is something which is at the midterm achievable. So at 3 to 5 years, something like this.
Okay, maybe just you opted mostly on P-type in your research. Yeah. So what was the reason that you did not look at N-type?
Well, we first thought that it's a value to stay close to PERC, but it's obviously not that big advantage. But the major aspect was to keep the aluminum metallization for at least one polarity. So this is a cost-saving aspect, and but if the aluminum metallization can also be applied to N-type, so it's not a big issue, the wafer polarity. For us, the most important thing is to reduce material costs.
Okay, you've shown actually several ways how to improve the cell. So how can companies cooperate with you if they are interested in utilizing your research?
Well, that's a very good question. So we are always open for cooperation, but of course we also need to involve some local manufacturers here as well. So our mission is also to support industry in Europe. So if we can find a way to include an aspect like this, then it's always possible to cooperate.
Okay, wonderful. Thanks, Robby. A few questions to Shawee. So when you look at actually, there are now some Topcon commercial products out there. So if you look at, and we maybe leave the LCOE part a little bit behind and look at it from a perspective of a testing institute and reliability. So how do you see them also performing in terms of quality also and reliability? Because quality with new product is obviously often also an issue because it takes time until you to optimize all these initial ideas. Can you maybe comment on that?
Yes. So I think that if I remember correctly, that starting from 2017, TÜV NORD has started testing, or we start to have the manufacturers sending us Topcon PV modules for testing or certification. So it's already 4 years past, and the mainstream or the good big manufacturer already doing all this kind of testing, including things like precise testing or the reliability evaluation, and as well as the outdoor evaluation. That means we install a real small scale module on the field over 1 year, collect all the data and see if it's either the performance is good as well as the reliability of these products in the field. Actually, field is good. So there are, of course, there are some different kind of points you have to be aware, such like in the Topcon, that the PID risk on the front side is higher, but now with all these years of production and optimization, that the cell itself has been already upgraded and adapted to the PID risk. And also there are the utilization of the POE instead of the EVA that also helps on this kind of thing. So I believe that during the years that this product with Topcon cell is already mature enough in the market. That's also why that all the research institutes that they are giving this trend of huge blooming in the near future.
Okay, I think that's it. Let's maybe quickly go to Leo. Leo, quickly. So you've been actually leading on the efficiency front at Jinko for quite a while on the Topcon level. So what's the secret? As much as you can reveal.
Yeah, when talk to the secret, yes, Jinko has been involved in the research and the development of N-type products since 2015. And until 2017, when the pilot line began, and then finally we announced the realization of full mass production in 2021. So we are also constantly refreshing the record of cell efficiency. So in my opinion, apart from the own technical advantages of Topcon technology, I think the accumulation of time and the technology is also critical. And also, I think recently, more and more manufacturers devoted themselves into the development of N-type technology. I think the concerted push across the industry is also of great significance.
Okay, I think so. It took quite a while because so the issue for Topcon obviously was always that there was this theoretical promise, but PERC actually developed also on the module level much better than many people anticipated, so that we always had on the commercial level less than 1 percentage point advantage, which was cost-wise not enough. Now you're expanding to 10 gigawatts, which is quite a significant amount among your total production. So when you look at profitability from your PERC products to Topcon, so what's still more attractive, and how will it change once you expand now to a 2-digit gigawatt level in terms of production?
So I think that the customers, they focus more on the power gain. I mean, what they ask as the most questions are what's the power gain, and what's the difference between the PERC and N-type Topcon, and as I have said, the bifacial factor, the LID, and the temperature coefficients, and brings great the power generation performance for N-type. And I think this is the most important key point for the N-type Topcon. And this is also why Jinko and other manufacturers, tier 1 manufacturers, will focus on N-type, because we want to make breakthrough for the model power, want to do the power climbing and break the cell efficiency. And apart from the increase of the model size, the cell size, we think the Topcon technology now, especially in 2022 and 2023, N-type Topcon technology will be the most important technology to replace the PERC, to be the next key technology in PV industry.
We've seen, because you're addressing so many different market segments, from residential rooftop to big power plants, and as we heard from your colleagues, the response is very good from the market. When you expand now, Jinko is one of the largest module manufacturers in the world. Will you now completely focus on Topcon? Does that mean that all your expansion will now take place on the Topcon level?
Okay, I understand. We have to do it step by step. I mean, the parity, even when we would do the parity or the capacity replace from Topcon from PERC to Topcon, I think it cannot be achieved by only one or two companies. I think the upgrade of whole industry is of great importance. So we will do it step by step. And Jinko, I think it's the first company to announce the 10 gigawatt, the commercial mass production of Topcon. I think it's like a great attempt and a brave attempt, I think.
Okay, wonderful. I think that's a great milestone. I think we're very much looking forward to that. That was very insightful. I learned a lot. I hope the audience as well. Thank you to everyone for participating to today's webinar. First of all, to the speakers. Thanks to the sponsors. Also, thank you very much to the attendees. I want to say thank you again. Have a nice evening. Have a nice afternoon. If you want to learn more about Topcon, please also download our latest report. End of last year, we've published a report on Topcon solar technology. It was the first exclusive report on this topic we've published so far. So it's fairly up to date. And what we're also doing, so this is, you can download that for free of charge on our website. What we're also doing now is on a monthly basis, we publish on our website efficiencies for the top commercial modules, and Topcon is obviously on the lower and on the higher end of this, or in the highest rankings of these tables. Take a look at our website. Once again, thank you everyone, and have a nice day. Bye-bye from the TaiyangNews team.
Thank you. Bye.